Hey guys, welcome to the video. Today we are going to talk about Avogadro number and we'll also talk about problems like how to calculate the number of atoms if you know the mass of a certain substance. So, what is Avogadro number and why does the name Avogadro show up every time you talk about such numbers? So, let me first say it out right here. Avogadro did not come up with a number. What Avogadro did say that the properties of gases they are determined by the number of atoms and molecules there are in the gases and not in the on the based on the nature of gases. These are this is actually the pretext of the gas laws, which we'll be talking about in another video. The link would appear in the screen itself. Now, coming back to Avogadro. So he did not come up with this number. He just said about this property. To be very exact, another scientist known as Jean Perrin, he dedicated the number that he discovered uh, to in honor of the great scientist Avogadro. Now, what is this number? So, as per the definition, it is the number of formula units or molecules as are atoms in 12 gram of carbon C12. This is a definition that is adopted by the UPAC in 1971. Now, let me tell you right here that this definition underwent a change in 2017, and now Avogadro number stands for 6.02214076 into 10 to the power 23. But for all practical purposes, you can use the definition, working definition, that is, it is the number of formula units or molecules as there are atoms in 12 gram of carbon C12. That comes out to be this number, or simply up to significant digits 6.02 into 10 to the power 23. So when I say I have got 1 mole of something, what I mean is I have got 6.02 into 10 to the power 23 items of something. Now remember, it's just like talking about a dozen of bananas. So when you say you have got a dozen of bananas, you mean you have got 12 bananas. Same way, when you say you got a mole of something, that means you have got 6.02 into 10 to the power 23 of that thing. Okay, but is that it? Actually, no, it gets pretty interesting just after that. When we talk about terms such as molar mass and molar volume, now because we'll be talking about gas laws in detail later on, but molar mass, as the word itself says, it's the mass of 1 mole of substance. And what is 1 mole? 6.02 into 10 to the power 23. So mass of 1 mole of any substance, that's the molar mass. So as it happens, it's numerically equal to the formula mass. So if I say 1 mole of carbon dioxide, that means the formula mass of that is carbon 12, oxygen 16 times 2, that's 32, that comes out to be 44. So the molar mass is numerically equal to the formula mass. So when I say 44 grams of carbon dioxide, that will be 1 mole of carbon dioxide, and that will be 6.022 into the power 23 formula units. Now, this thing can be used in a very interesting way for stoichiometric calculations. Now, there's a separate video on stoichiometric calculations which will be linked just down below. Now, let us do some calculations. For example, calculate the number of oxygen atoms in 106 gram of sodium carbonate. Now, two things you should be very much considerate about is oxygen atoms. Now, if we remember carefully, remember 1 mole equals 6.02 into 10 to the power 23 formula items, right? So that means 6.02 into 10 to the power 23 sodium carbonate formulas or molecule. We can say formula items, not molecules here, because it's an ionic thing, and that would be equal to the molar mass of Na2CO3, which is how much? 23 times 2 for sodium plus 12 for carbon plus 16 times 3, that's 48. Now if you do, that's 46 plus 12 plus 48, that goes to be around 106. So when it's said 106 gram of sodium carbonate, so that comes out to be 1 mole of sodium carbonate, right? That means 6.022 times 10 to the power 23 Na2CO3. We have to calculate oxygen atoms. So one sodium carbonate has 3. So 6.022 will have 3 times 6.022 times 10 to the power 23 oxygen atoms, right? And this comes to be around, I think you are doing the maths correct, that's 18.06 times 10 to the power 23 oxygen atoms. I hope this makes sense. Now, there's something that I want you to work on and find out, and we'll discuss that in next video, because we also want to talk about volume. So what is molar volume? Again, molar volume is the volume of 1 mole of any gas at STP. Now what is STP? STP is standard temperature and pressure, right? So what's the standard temperature? That is 273 Kelvin, that is 0 degrees Celsius. And what's the standard pressure? That's 1 atmospheric pressure. So as it happens that volume of all and any gases at STP equals to be 22.4 liters, right? Now based on this information, again we can have a lot of calculations and problems. So here is a problem for you that I want you to work on, and we'll discuss this in the next video. Calculate the number of nitrogen atoms. Remember, again I'm asking about atoms, but nitrogen as a gas exists in the dinitrogen form, that is 2 atoms combined as a molecule. And remember, 1 mole is molecules of formula units. So 11.2 liters of nitrogen gas at STP, how many nitrogen atoms would you find? Now solve this and let me know down in the comments, and we'll discuss more problems on molar mass and volume in our next video. Thank you.
We hope you like this video. Press subscribe, thumbs up, and stay geekly.